Hello, and what I want to do today is introduce you to this little button board that I make. It's remarkably simple and pretty useful, actually. You can use it in a number of different configurations. And so I'm going to give some demonstrations and show you how you can use it. To start off, though, what I'm going to do is I'm going to show you how it's actually made. Here's the actual drawing of the board. Okay. And in its most basic configuration, probably the most commonly used way, is going to be with the three-wire hookup. So we're going to have signal, we're going to have positive, and we're going to get ground. And you can see what happens. For as long as the power is supplied to the board, it's going to feed electrons up through this resistor. There's a 10K resistor here. And it's going to then essentially charge this entire side of the button. Now, normally the way these work is these two are obviously connected. You can see that here, and these two are connected, but these two are not, unless the button is depressed. Depressing the button is essentially shunting it, like dragging a screwdriver across these two. It'll allow the electrons to flow from one side to the other. So if we have electrons flowing up into this resistor, piling up here, the other path they have is to go to the signal pin. Okay, so that means essentially that the signal pin is going to be getting pulsed by electrons, or pulse, but fed electrons, which means it's going to be high. It's going to be getting positive voltage to it. Now, when I depress the button, what happens is these two are now connected, which means we have a path of lower resistance, and the electrons are free to flow into ground. When that happens, this pin goes low. So under this normal operation, and I'll demonstrate it here, you'll see that normally if the button is not depressed, the signal will be high, and if the button is depressed, the signal will be low. So let me go ahead and get this guy hooked up. I'm just going to use a standard 3-wire connector and plug it in, and I have a little piece of code. So let me pause it, and I'll get it all set up. Alright, so I've got it hooked up. You can see I've got a 3-wire connector going to my button. On this board here, the yellow wire is connected to signal, the one closest to the chip. The red wire is hooked to the 5-volt supply. This motherboard is set at 5 volts right here. And the black one is ground. And of course the switch is hooked up appropriately with the signal, power, and ground along this back side. Okay? The code I'm going to use is really quite simple. What I've done here is, of course, open up a serial port. I'm going to be using the LED, the onboard LED. So that's hooked to pin 13. I'm going to set it to output so that I can turn it high or low. And I'm actually going to hook my switch, or I already have, hook the switch up to pin 14. And I've set it to just a straight input. Okay? So now, keep in mind again that the state of the button when charged is going to be normally high. So in this particular case, I'm doing a simple if condition. If the digital read of pin 14 is low, then let's turn on the LED and have it say button pressed. And if not, well, then let's turn it off. And you can see that if I push it, oh, can't see that there. If I push the button, in fact, it works great, and the LED lights up. Notice if I hold it, it just scrolls on down, and that's because I'm running this thing at a 100 millisecond loop. Alright, so the next thing I want to show you is you can use this button without using the power, and you can use it just as a regular old switch. If I do not hook anything up to positive here, if I just leave it floating, essentially what I have is between signal and ground is nothing more than just a switch. Okay, so I'm going to build a simple circuit with that, and I'll be right back. Okay, so here's a very, very simple circuit where I have the positive going to this bus of my breadboard, which is currently hooked to a 10K resistor, which is feeding the positive side of the LED, which is then going to one side of the switch, and of course the other side of the switch is going to the ground, with the center pin, see if I can get that oriented so you can see it, is floating and nothing is connected to it. So when I push the button, it becomes nothing more than just a switch. Alright, so it's actually just going straight from signal, jumping across when it's depressed, straight to ground. Okay, so let me set up another demonstration and I'll be right back. Okay, so in this demonstration, I'm going to use it exactly as I did in the last one. I'm simply going to be using the signal in the ground, ignoring the center pull, but I'm going to be using the Arduino pull-up function to be able to make this system go. So in this case, the only thing I've changed in the code from the last one is I've actually called up input pull-up. What that's going to do is it's going to essentially open up an internal resistor and flood that pin with a source of electrons so that it's always charged. Okay, so if I ask it, hey, do you have a charge or not? Are you high or not? It's going to say, yes, I am, because you've connected me to a resistor, which is hooked to the source, and that pin is charged. So when I push the button, though, that's going to give a pathway to ground. If we look at how I've actually wired it up, you can see that I'm using, again, these same two outer pins, and I've simply connected it to pin 14, which I'm currently charging with the internal pull-up resistor, and to ground. So when I push the button, okay, it will then allow those electrons to flow to ground, and you can see that it works just fine, and the LED lights up, and everything is great. All right, so let me show you one more demonstration, and I will be right back. Okay, so in this final demonstration, I'm actually going to use the resistor on this as the resistor for an LED. Mind you, this is 10K, so it's going to make the LED light up rather dimly, but it still works. So in this case, if we completely ignore the signal, you can see that if I were to follow the electrons, if they were to come in here, for example, they would then enter the resistor, come over here, run up to this side of the switch, and then if I depress the switch, that would allow those electrons to flow out this other. So again, this case, I'm using the positive and negative and passing those electrons through a resistor. So if we actually look at that physically, you can see that I have removed the resistor. I have the positive wire going to the positive side of the LED. I've got ground coming over here. I've hooked it up to what would be the positive wire. And then I have the negative wire going to ground. So therefore, when I depress this button, the electrons are going to have to flow through the resistor. And in fact, it works just fine. Okay, so that's all I really wanted to show you, and I hope you find this useful, and I will see you again soon.